Hello everybody. Today we are going to be working on day one notes, which is to simplify radicals and solve by taking the square root. So first we're just going to go through some review problems of how to simplify radicals. This is something that you should have learned before, so I'm going to go a little quickly. If this doesn't feel familiar or you're lost, just make sure you're reaching out so I can get you some extra videos to help you out. So when we have the square root of 500, we're going to make a factor tree. So two numbers that multiply to 500 I know are 5 and 100. And you can use any pair of numbers that multiply. Okay, then to get 100, I know I can do 2 and 50. And 50 is 2 and 25. And 25 is 5 and 5. So now since it's a square root, that means we're looking for numbers that could have multiplied by itself to get that number. So anytime that I find a pair of the same numbers, I'm going to circle one and cross the other out. And then I also see I have a pair of 5. Now this 5 does not have one to pair with, so that's a leftover. So anything we circled, anything that had a pair can move to the outside of the radical. And anything that's left over goes inside. So we're going to get 10 root 5. Another way you could think of this is we could break the square root of 500 into the square root of 100 times the square root of 5. The square root of 100 is 10. So that also gets us to 10 root 5. So sometimes the second way I just showed you is a little bit easier for numbers that have an obvious big perfect square in them, like 500. But sometimes the first way I showed you is easier when it's not obvious what perfect square you could use. All right, if we look at number 2, if we're multiplying two radicals, we want to multiply the numbers inside the radical first. So 6 times 8 is 48. And then I can factor tree, so we know that it was 6 and 8. And then 8 is 3 and 2. And 8 is 4 and 2, which is 2 and 2. So I've got a pair of 2's and another pair of 2's with a leftover 3. So I'm going to have 2 times 2, root 3. So I get 4 root 3. All right, then let's take a look at number 3. So again, I'm going to multiply. Since there's no number outside the second radical, the 3 doesn't have anything to multiply with. So it's just going to be a 3 on the outside, and 12 times 6 is 72, which I know was 12 and 6, which is 6 and 2, and 3 and 2, and 3 and 2. So I have a pair of 3's and a pair of 2's with a leftover 2. So I keep the 3 that was on the outside, and then I'm going to multiply it with the 2 new numbers I'm pulling to the outside, and then I leave a 2 on the inside. So 3 times 3 is 9, times 2 is 18. And there we go. And I know with those kinds of problems, there are certainly a lot of shortcuts that you could take along the way if you see them. I just prefer to show you guys how to do it the long way. And then if you see and understand those shortcuts, I'm fine with you doing it. But for some people, shortcuts can get really confusing. So I like to just kind of show the full way. And then if you see and understand the shortcut, you're definitely more than welcome to use it. So if you notice patterns that work, you can do that. All right, for number 4, if we have a fraction underneath a square root, we always want to split that into 2 separate radicals. So root 2 over root 11. Now, one of our big rules for simplifying radicals is that we cannot leave a fraction a radical in the denominator of a fraction. So that means that I need to rationalize the denominator, and I do that by multiplying by root 11 over root 11, because that's really just a fancy form of 1. So root 2 times root 11 is root 22. And then on the bottom, root 11 times root 11 would give me root 121. And the square root of 121 is 11. All right, and if we look at 25, we're going to start with the same thing. We're going to split it into 2 separate radicals. So root 25 over root 3. And then to rationalize my denominator, I'm going to multiply by root 3 on the top and bottom. And hopefully you notice on the top we had root 25, and that equals 5. So I'm going to have 5 root 3 over 3. And then something that you always want to check for in the numerator is to see if you can simplify that radical any further. Like we can't simplify the square root of 3, or in number 4, we couldn't simplify the square root of 22. So both of those we were finished. But if you can simplify that radical, you want to make sure you do it. All right, we are going to skip over 6 and 7 and take a look at number 8. So again, we have to rationalize the denominator. And so we have 6 root 8 over 8. And then root 8 we can simplify, because if we make a factor tree, that would be 4 and 2, which is 2 and 2. So we have a pair of 2's with a leftover 2. So this is going to become 12 root 2. And I got 12 because I multiplied the 6 with the 2. And that's still over 8. And then I can simplify 12 over 8, and that's going to give me 3 root 2 over 2. All right, so that was just a quick refresh on how to simplify radicals. Again, that's something that you should have previously learned. So I went through it a little fast. If you need some help, just make sure you let me know. All right, if we look at number 10, the directions say to solve by taking the square root. So when we do that, that means we want to isolate the thing that is being squared, so then we can square root both sides. So first thing I'm going to do is add 289 to both sides. So I get x squared equals 289. And then I can square root both sides. It's really important to remember that whenever you take a square root of both sides, that you have to put a plus or minus symbol in front of it. So you should automatically do that. And then the square root of 289 is 17. So that just means that our answer could be positive 17 or negative 17, which makes sense because if we were to square either of those, it's going to give us an answer of positive 289. So we're just going to take a look at some more complicated problems where we're going to solve by square roots. So again, our goal is always to isolate whatever is being squared. So if I look at number 11, I'm going to start with adding 6 to both sides. So I have 4x squared equals 48. And then if I divide by 4, I get x squared equals 12. Now that the x squared is by itself, I can square root both sides. So I get x equals, and then I automatically put my plus or minus. Now 12 isn't a perfect square, so I want to make a factor tree for it to simplify. So I'd have 6 and 2 and 3 and 2. So a pair of 2's with a leftover 3. So that's going to give me plus or minus 2 root 3. If we look at number 12, first I'm going to subtract 3 from both sides. So I have negative 5x squared equals negative 12. Then I can divide by negative 5 on both sides. So I get x squared equals 12 over 5. Then I need to take the square root of both sides. Now we know that we're going to split this radical in two. I'm going to do my work off to the side up here just because I'm running out of space. Now before I rationalize the denominator, I'm going to simplify the numerator. Now we just simplified root 12 over here, so I'm not going to show all the work again. But so we just know that that numerator is going to be 2 root 3. And again, we know that because we just did it. So then to rationalize the denominator, I'm going to multiply by root 5 over root 5. So then I multiply the numbers under the radical together. So I get 2 root 15 over 5. And remember, we can't simplify the 15 with the 5 because the 15 is under the radical. We have 2 root 15 over 5. All right, let's take a look at number 13. So first thing I'm going to do is divide by 3. And then I've got x minus 2 squared over 7. So now this whole parenthesis is being squared, so I can square root at this point. So then I have x minus 2 equals plus or minus root 7. And then I can add 2 to both sides. So I get x equals 2 plus or minus root 7. And if we look at number 14, to clear out that 1/5, I'm going to multiply by 5 on both sides because a fraction gets cleared out by multiplying by the reciprocal. So I've got x plus 4 squared equals 30. Then I can square root both sides, and I get x plus 4 equals plus or minus. If we make a factor tree for 30, I've got 15 and 2, which is 3 and 5. So we don't have any pairs of numbers there, so that means the square root of 30 doesn't simplify any further. I just have plus or minus root 30. And then if I subtract the 4, I get x equals negative 4 plus or minus root 30. All right, for these last two problems, we're going to just use the falling object model or falling object equation to solve problems 15 and 16. Just as a reminder, the H over here stands for ending height, and this is read as H0. I believe naught is the word for 0 in Latin, and that's why we call it that. But that's going to be our starting height. And then obviously T stands for time. So it tells us a coyote is standing on a cliff 254 feet above a roadrunner. If the coyote drops a boulder from the cliff, how much time does the roadrunner have to move out of its way? So in this case, the ending height would be 0 because we want to know when it's going to hit the road. And we're trying to solve for T, right? Because it's asking how much time. And the starting height is where the roadrunner, or where the coyote is at 254 feet. So then to solve for T, we can subtract 254 from both sides. So negative 254 equals negative 16 T squared. Then in your calculator, you can do negative 254 divided by negative 16, which is going to give you 15.875. And for problems like this, it's okay to use decimals because if we're talking about seconds, it makes more sense to give our answer with decimals. Like people don't usually say like, oh, like you did this in 15 and like 7/8 seconds. No, you would use a decimal. So that's how we're going to answer these questions. Then we would square root both sides. So then we get plus or minus. So I'm going to do that in my calculator. And remember, in this class, we round to 3 decimals unless the directions say otherwise. So 3.984 is what I got. But now we want to make sure, since this is a word problem, we want our answers to make sense in the context of the problem. And since we're talking about time, we wouldn't give the positive and negative answer. We would just give the positive. So we're going to say 3.984 seconds. All right, and then let's look at just one more example. It asks, how long will it take an object dropped from a 575-foot tall tower to land on the roof of a 235-foot tall building? So remember that the ending height is what comes first, and so we want to know when it's going to land on this homework. So, sorry, not this homework, on this building. I don't know why that word came out of my mouth. So we're going to do 235 equals negative 16 T squared. And again, it's asking how long, so we know we're solving for T. And we know that the starting height is 575. So if we do 235 minus 575, that gives us negative 340. And then if we divide by negative 16, we get 21.25 equals T squared. And then if we square root both sides, we get plus or minus 4 point, we'll round to 610, because it should be 4.6097, so then it rounds up. And again, we're talking about time, so we would want to give the positive answer. So we're going to say 4.610 seconds. Alrighty, so that is all I've got for this video. If you have any questions, make sure that you try rewatching the video, and then make sure if you're still confused that you reach out to me for some extra help. Good luck.